Welcome to Swayam Prabha series in computer science. In this series, this is a course on artificial intelligence and we are in unit 5 on module 37 with a continuation from the last time where we dealt with different prompt types and the components. This is going to be a conceptual overview of what an LLM is. Last time we saw how the prompt structure should be. Here we will see how the LLMs are and what are the different types of LLM, and suppose we write programs to LLM, what are the things that we should consider, like the temperature, context window or tokens, and what are the free platforms that are available. I will just give an overview of that and then we will go into the practical aspects of it, where we will see the different types of components and the zero shot type of learning. I will give some examples. We will feed it into ChatGPT and see the result. Now, what is a large language model or LLM as we call it? It is trained on enormous number of data or the text in order to predict the next word or token in a sequence. In previous sessions, we have dealt with BERT technique or the attention mechanism. The same attention mechanism, or basically those mechanisms was what is it in place towards large language model also to predict the tokens. Now it learns the different things like the language and grammar, facts and the reasoning patterns, like what we did in the previous session, or like the thought, chain of thought or tree of thought. And it can also learn the different programming or writing style based on the user. What is the key insight towards it? It is, instead of memorizing the answers, it predicts what is likely to be next. And this prediction, again, it refers to the attention mechanism that we did internally. And how does it get trained? It is through the enormous text that is available in the internet, which are through books, web pages, or Wikipedia, or the research papers, or the code or the news, the code, enormous code that resides in the web, such as GitHub, or the news material. So number of data or the text material that is available in the internet is taken and learned and developed as a model. So the standard LLMs that are available today as of now, and I have listed only a few here, there are plenty available. The familiar ones are the GPT-5 based, with the organization is OpenAI, you might have learnt about it, where comes the ChatGPT portion right here. The other one is Claude, owned by Anthropic, Gemini, owned by Google, Llama, owned by the Meta, Mistral by Mistral AI organization, and Qwen by Alibaba. These are some of the organizations which holds the model. Again, there are also some by NVIDIA and other things which I have not mentioned here. We can take a look at it. And the common task that these LLMs could do is either chat and conversation, coding, summarization, translation or brainstorming. This we have, a few of it we have dealt in the last session also. So an example prompt is, summarize this research paper, where all the LLMs can do this kind of task. As it can also do the languages translation, generate emails or text, create the lesson plan, solve math and explain concepts. Number of use cases are there. Say for example, prompt can be explain recursion to a 10-year-old, where explain, if you look back into the previous prompt component, this explain is a directive, explain recursion is a directive, and to 10-year-old is the audience where the context is described. Another prompt would be, write Python code to sort a list. This is straightforward. So, there are some of the examples that can be given to an LLM. So, the general purpose LLM, the same model, it can write poetry as well as generate Python code. Like the same model of ChatGPT can do multiple things at once. Now, how does it generate text? We have the input prompt. Inside LLM, it tokenizes in the sense it splits into different components So for our eyes it can be, say, maybe a word is a token, but a punctuation mark or the comma or some other say the aspects also can be a token in a statement. So after this tokenization it can be given to a neural network. This we have dealt in previous classes. In the neural network, how the embeddings are created, and from the embeddings how the training is done, all that we did a part of it in the last few classes. And based on the training portion it predicts the next token, and this repeats again and again. This portion where the prediction and the neural network portion is repeated again and again until we get the final response. Say for example, suppose the input is the capital of France. If the first prediction is Paris, the second prediction is full stop, and the third prediction is it. After softmax layer, if you remember the softmax layer, the probability, there might be a higher probability towards Paris. So it based on the probability measure, it would calculate which predicted value is the utmost and then gives the final response according to it. So the response grows actually one token at a time, although for our eyes it appears as such a full generated content. So, and first question is, now we are going into the details of different types of LLM, not types of LLM in the sense the different context of LLMs of which jargons that they use. The first is the token, and why token? Because it is very essential when it comes to the cost also. So here the token can be a word or a part of a word as I specified earlier, a punctuation or a space, a number. For example, AI is amazing. AI is a token, is amazing, is a token, amazing is a token. And if you take this word unbelievable, unbelievable, there are 3 tokens. So different LLMs have different tokens. What you have to understand here is LLMs or ChatGPT or any type of LLM, it does not see the complete sentences, all it sees is the tokens. Now why does it matter? Because this is what is the cost. The cost that we pay for subscription is based on the tokens. So every interaction that you give, the prompt that you give, it is based on the input and the output tokens that constitute towards the total token. Suppose you take this example, prompt is summarize this 20-page document, you feed that document, you attach that document to an LLM. Assume that that input has 6,000 tokens and the output that is given from the LLM, this is the input is the prompt that you give and output is generated from LLM. The total number of tokens is going to be 7,000 and the limit that the LLM specified is 8K limit, 8,000 limit. So if the limit is exceeded, suppose you give the prompt as 8,000 and the output as 1,000, then it would remove off the earlier 1,000 and it will only give 7,000 plus 1,000. It would remove off the older one. So this is essential. So whenever you give a prompt, see to it that the tokens is actually matching. Otherwise, you may not get the correct result. The second, say the word or the jargon is the context window. First we saw what token is, now we will see the concept of context window. The context window is actually the model's working memory in the sense when we give a prompt to the LLM. So what happens inside or what all that constitute in the sense like system prompt is the starting prompt that the system gives, like hello, how are you, or what can I do for you. Those are the system prompt that is generated from the LLM side. And the conversation history. So in ChatGPT you give some prompt, it gives back the result, again you give the some input and again it gives. So the whole history is the conversation type that is specified. Okay. and the uploaded document, suppose you upload the document along with some prompt. So, those things and the prompt plus whatever generated from LLM. So, all these combined form the context window as such. So, a 128K token context window can remember a very large document. In the sense, if you have a large context window, then it is better. You will get more better result. So, whenever you look for any LLM, look for largest context window. So, it give whenever you have a large window, it gives larger conversation, like other use cases can be a book analysis or a research paper analysis or some document comparison. This is some of the use cases with which you can try out context window. Another jargon is the temperature, where it controls randomness and creativity. Now, we will deal with temperature, where it deals with randomness and creativity. Temperature, if it is going to be very less, actually it goes from 0 to higher side, and if it is towards the higher side, it would be more creative, more diverse and less deterministic. And if it is towards the low temperature, it is more predictable. Suppose if it is going to be 0, it is deterministic, it is actual, it is correct, like predictable, it is more consistent and higher accuracy, and if it is high, it is going to be on the other side. For example, the prompt is write a title for AI workshop. If temperature is 0, it would give an introduction to artificial intelligence. If it is higher, it would be slightly creative, and when it is high temperature, it would also lead to something which is not relevant also. So, there should be some trade off between where we use the low temperature and high temperature. We will do a small exercise also on this in the either in this session or in the next session. Now, another keyword is top P sampling. So, whenever we mention LLMs, we would mention the temperature, context window and top P sampling. This means we would take the possibility words that is into account. How many tokens that the model considers, and we can specify this top P also. So, when we specify top P, it is mostly the highest probability words that we can consider, and when we say high top P, consider all the possibilities. So, we will have more variety to it. Suppose you take this example, say we are giving the prompt the capital of France is, and the LLM, suppose that is the output of LLM, there are three things: Paris is 50%, London 20% and Rome 15%. Suppose if we give top P equal to 1 or close to 1, we will get all the three results here. Every option is considered. Suppose we give top P as 0.6, which is less compared to 1, we will take one, it will take only 50 and 20%, it will give back the answer as Paris and London. If it is close to 1, it will give Paris, London and Rome. So, again it is based on the user type, it would give back the answer. Now, another keyword is the maximum token. Maximum token, it limits the response length. Suppose for example, we say explain machine learning, and ideally explain machine learning, by default it would give as maximum token 20, but suppose we want it to expand a bit and give it as more in detail, we can specify the maximum tokens to be 200, so that there will be a good explanation to it. So, it works in both ways. If it is very less, we can expand it more, or if it is much more, we can compress that. So, now what are all the parameters that put together is given here. Say that if it is going to be temperature, it controls the creativity, and the use cases for code generation or for using code, we would always want the temperature to be 0. And if we want to generate a story or generate some video, then the creativity should be more, therefore the temperature we should give as high. And for top P possibilities, this is the diversity that we have, and for accuracy we will give low. If we need more variety, we will give the top P value as high, as we have seen in the last example. So, here is an example where coding assistance is 0.1, top P as 0.9, and maximum tokens we will be giving as 400, because the coding is finite. Whereas for creative story, this is a use case where the temperature is 1, so that the generated text will be more, and sometimes there can be hallucination too, and that need not be worried in the case of story generation. Whereas hallucination in the case of code, it is very much redundant, or it is not needed. So, we will not give temperature as 1 for coding, and top P it's 1 because we need more varieties in the story, and a creative story for maximum tokens, because it is generated text, it should be around 1000 or more. For coding it can be only 400. How do we access LLM? See, so far we have seen the different keywords for LLM that is necessary, and suppose we are computer programmers, we want to access LLM from our end, we want to write code using LLM, then we would use something called as API. APIs, applications, those communicate programmatically, and the interfaces, some interfaces I have mentioned here like ChatGPT, Claude or Gemini, and through API we will be communicating with that particular interface. Sometimes those LLMs we can host it in our own machine itself. For example, Llama or Mistral, there are some open source LLMs available that we can install it in our own machines, and using APIs from our own machines we need not communicate over the internet, but we can use it within it. Say how it actually works, the user will write the program through the API that will interact with the LLM. That LLM can either be in the internet like the chat interface that we have, or it can be within our own machine like Llama or Mistral, and through that LLM we can get the response. So, the API is the application peripheral interface that allows to interact with LLMs. So, the same thing that I have said before. So, common use cases where we would want to write our own code using LLMs, like for example chatbot and virtual assistant, customer support automation. Suppose I want to write a chatbot or a customer support automation for a particular industry using an LLM, we can use APIs. Coding assistance, search, education, tutoring system, these are some of the use cases where we use the APIs. The next is the important one, the subscription and rate limits. So, there are some free subscription plans that are available, like ChatGPT provides some limit, but after a few minutes it would say yes, until this time it is free, but after that upgrade it. So, there are some limited usage, and basic model access is available for multiple LLMs, and there are the paid limits also, and when we pay there are higher usage limits and better models available where it can be accurate. May be accurate or not, we do not know, based on the user requirements. And there are some priority access, sometimes it would say there is no access for this model, so you have to pay. And the rate limits, what is the cost per rate? The rate would be either request per minute or tokens per minute, or sometimes they would give as daily quota. Daily, this is the quota that is given daily, and we might have to log into the next particular time in order to get the answer. So, otherwise it may fail. And overall what we have seen so far, the conceptual overview is LLMs can generate text one token at a time, it cannot see as such, and these are the basic processing unit is the token. And some of the keywords that we have seen is the context window that comprises the entire thing, like the system prompt, whatever the prompt that we give, as well as the response, the uploaded document, everything constituted towards the context window. and the parameters like the temperature that controls the creativity, top P that gives the variety, and the maximum tokens that gives the response length, whether we want the response to be short or more. And the LLMs, it is not only available through the internet, but we can write code and generate our own apps through LLMs, and it can either be through the internet or we can install in our machines and access that. So, these concepts are essential in order to program it effectively. So, what we will do next is I will go through some of the demo session for you with a few exercises of what we have learned, but before that just check a small prompt of write a welcome message for first year engineering students. Suppose if we keep temperature as 0.1, then the expected output would be very formal, consistent and predictable, but if it is going to be 0.8, then it is friendly, varied and more expressive, and if it is going to be 20 tokens, it would be a short greeting. We can check that, and you can write this and check for different temperature and tokens. So, that would be an exercise for you. If it is going to be 150 tokens, you can see that it would be a detailed welcome with for first year engineering students, and top 3 as 0.3 and 0.95, you can see how different does it make with the different conservative wording, and in this case it is going to be diverse vocabulary. Now, we will look at a few of the demo session where we will have the example prompts and the output here. So, if you see in the last session we saw about zero shot prompting. So, you see here I have the ChatGPT interface. So, what we are going to do is I will take a few of this like the zero shot prompting, classify the sentiment of this review as positive or negative. I will just take this, and if we just give this prompt here, it would give back the result as negative. And these are the other 3 examples here, just due to time I am not giving it. And in one shot prompting, if you see we are giving one example here. If you see the prompt is classify the sentiment of each review as positive, negative or neutral. We are giving one example, the food was cold, the sentiment is negative. Now, based on this example, it will give the sentiment. This is another example. For few shot prompting, I am taking the one example where if you see here, I am just doing it. Classify, this is the prompt that is being given. Classify the sentiment of each review as positive, negative or neutral. There are 2 examples that are given. Amazing service and delicious food, it is positive. The package arrived late and damaged, it is negative. Third example, the product works as expected, it is neutral. Now, based on these 3 examples, I am asking ChatGPT to mark the sentiment of this review. The battery life on this phone is terrible. Then the response that it gives is negative. So, there are other examples that is listed here. Now, I am giving an example prompt for chain of thought. So, take this example. Reena has 12 mangoes. She gives 3 to her friend and buys 5 more. Think step by step and then give the final answer. How many mangoes does she have now? So, this is a chain of thought where ChatGPT would say Reena starts with 12 mangoes, give away 3, then buys 5 more. Final answer is 14 mangoes. Actually, if you have a better version of it, it would give the step by step analysis here. If I give step by step reasoning, it would give the details, yeah, it is a concise solution. Start with 12 mangoes, give away 3, so 12 minus 3 by 5 more, therefore 14. So, this is what is required. Now, it also says I can provide my private reasoning process. This happens because it thinks that it is we are asking how the ChatGPT is itself reasoning out, that we are not saying, we are just asking how say arrives at the answer. So, suppose this 0 shot, I will give you tree of thought example here, where suppose the prompt is this, a student has, then choose the yeah, suppose if we give this prompt, this is an example for tree of thoughts. A student has an exam in 3 days and wants the best study plan. Explore 3 options. Option A is read notes only, option B solve practice questions only, option C is 3 mixed revision and practice. And for each option we are asking LLM to give one advantage and one disadvantage, and along with this we are also asking the LLM to choose the best plan. Now, if we see the response, see how beautifully it gives comparison of 3 study option. Option A, read notes only with advantage disadvantage, solve with each of the advantage and disadvantage. Now, it also gives the best plan with option C, and it also gives the schedule like what we needed. Another one would be the graph of thought, where the graph of thought where we say an example is help a student to choose a laptop. Suppose this is the prompt for graph of thoughts. There are 4 factors that is to be considered. One is budget, battery life, performance and weight. And for each of these factors, and each factor here we are going to have it as a node in the graph. For each factor, explain that separately and how each factors influence one another. See, in tree of thoughts the nodes will not interact, but in graph the nodes interact, like the battery life can interact with performance or battery life with weight and so on. So, in this type the graph we can see that it also gives the different nodes. Along with the nodes, it would also give a graph that the user can understand, and we can also get multiple graph structures by giving additional prompts to it. So, at last it would also give the recommendation type. So, this is a short demo of the different components of prompts. So, in this session we have seen the overview of LLM and also the different types of demo of prompts. Okay. And in the next session we will see a few more additional examples and an API call using LLM. Thank you.